Hello student, welcome to distance learning with Nitendra Acharya. This video is for graded BLE student and it is a part 2 of algebraic expression. In part 1 we studied, we did some few introduction and definition of algebraic expression. We started factorization of binomial and trinomial uh, and polynomial also having four terms and only by taking common. Now it's of difference between two square. The algebraic expression which are as a difference of two square. Now it is a beginning for a very popular formula, very useful formula, a square minus b square formula. So let's see what's the formula is. Factorize. We are going to derive the formula. Factorize a square minus b square geometrically. We are going to do geometrically first. For that, now it's a square. You can see it's a square and it's all sides. The property of a square is it's all sides are equal, it's all angle are equal and they are 90-degree. Opposite sides are parallel, opposite sides are equal and parallel also. So this is a square. It has its measure a, all sides measure a. So we can you can easily tell students that its area is a square, because the formula to find the area of a square is L square, or you can say side square. So from this square having area a square, let's take a small area. Let's take out a small area. That's b square. This area is, it's just we cut it and we take it out. We take it out. Now the difference will be a square minus b square. The difference, now the remaining part, isn't it? The remaining part which you can see here, right here, the remaining part will be a square minus b square. That is a square minus b square is a remaining part. After we take this part out, this with different color b square part, this is also a square, it's all sides are equal, all sides are b, and if we take this part from a bigger square a square, now the remaining is a square minus b square. Now we cut that part also. You can see, just see what we just cut that part, and the remaining part from here to here will be the side of this remaining part will be a minus b. From here you can see, let me, from here, right here, it's a minus b. Now this part, where does this part goes? Now we apply this part to another side, it's there. Now it's the same part from which we took out from here, it's the same part which we have kept here, kept right here. We took it from here and we pasted, we cut from here, we pasted here. Its side will be b, it will be b, because this part, you can see it's b and this part is also b, so it's this part from, it's this part, so it will be b. Now what will be this part, what will be the value of this part, what will be the measure of this part? So you can easily guess, this part is equal to right here, this, so it will be a minus b, a minus b. Now let's see a bigger rectangle. Okay, now from this part will be, from here to here it will be, up to here it's a, isn't it? Now we can say it is a plus b. From here to here it's a plus b. Now it's a rectangle a, b, c, d, isn't it? Now if we subtract a square minus b square, then it will be equal to area of rectangle ABCD, because this part is this part is taken out from here and pasted right here. Now it's same a square, isn't it? It's same a square part, a square minus b square part, isn't it? It's same. The whole complete part, complete from here to here, is a square minus b square, because the part which is taken from is pasted right here. So it is a square minus b square, and so a square minus b square, a square minus b square will be area of rectangle ABCD. Now, what will be the area of rectangle ABCD? We all know length into breadth is the formula to find the area of rectangle A into B. Now, we have to note that area of rectangle ABCD is for rectangle ABCD, length L is equal to AB, which is from A to B, it's A plus B, and breadth B is equal to BC. From B to C, it's A minus B. So we have to replace L by A plus B and B by A minus B. A plus AB into BC, which is A plus B, A minus B. So our formula is therefore A square minus B square is equal to A plus B, A minus B. Now it is the most easiest way to factorize A square minus B square geometrically. Okay, hope you understood it. Let's proceed to next slide. Factorization by applying formula A square minus B square. It's type 2. Type 1 is in part 1 and section A. It has two sections, A and B, three sections in fact. Now you can see on the right of your screen there are the squares. 1, 2 square is 4, 3 square is 9, and up to 20 there is 20 square is 4. And they will be useful to you. Now example 1. First question, simple question. Solution. First we have to remember what we are doing. We are just trying to create difference of squares. Now here a square is already in the form of a square, but 1 is not in the form of a square. So you can see there in your screen on the right side, 1 is the square of 1 square. So what we have to do is, we have to, instead of 1, we have to write 1 square. Now a is already in the form of square, so we use bracket and we write in the form of whole square. And 1 also, 1 you can see here, it's 1 equal to 1 square. And now our question is in perfect form. It is in the form of difference of square. Now it is exactly in the form of difference of square, which we can write a square minus b square. Now we know the formula of a square minus b square. We know a square minus b square is equal to a plus b, a minus b. Now we have to be sure about what is the value of a and what is the value of b. We can easily link from here. It's a is a, so we don't have to worry about it. A is a, and what is b? B is only 1. B is 1. The value of b is 1. Value of a is value of b is 1. Value of b is 1, and value of a is a. So we have to replace in this formula, right here in this formula. After writing, we know we have to replace a by a, so that won't be any replacement, but b will be 1. Now let's see the replacement. Now it is the confirmation that a is a and b is 1. Now a will be a, b will be 1. You can see here, a will be a, b will be 1, a will be a, and b will be 1. Now in this way it's over. A square minus 1, the factorization of a square minus 1 is a plus 1 and a minus 1. It is as simple as it is. Okay. Now let's quickly move to another example. Factorize 2. Example 2, factorization. Solution. Here, this is our question. 169x square minus 225y square is our question. Now 169, where we can see 169 right here. It's right here, 169. Question to a student: 169 is a square of which number? Now we can see from this table from on the right hand side of your screen that 169 is a square of 13, isn't it? 225 is a square of which number? 225 is the square of 15. So we have to convert this algebraic expression. We have to change this algebraic expression as a square of terms, as a difference of square of terms. Difference of square of terms. Now how can we do it? How can we do? You can see it's 169 is a square of 13 and 225 is a square of 15. So what we have to do is we have to write 13x whole square minus 15y whole square. Now our question is in perfect form. It is in the form of square, difference of square. So it is in the form difference of square. So which is a square minus b square. Now it's clear that a is 13x and b is 15y. So we know we have a square minus b square is equal to a plus b and a minus b. And now it is a confirmation that a is 13x, which we have already noticed, and b is 15y. Now a will be replaced by 13x and b will be replaced by 15y. Or you can see here 13x square minus 15y square is equal to 13x plus 15y. Now a is replaced by 13x, b is replaced by 15y. A is replaced by 13x, b is replaced by 15y. It's the answer. Now 169, that's the square. 15y, 169x square is a square of 13x, and 225y square is a square of 15y, which is in the question. We don't have to worry about it. It's exactly the question, same thing, isn't it? It's question. So only this part is our answer. Now it's over. Okay. Now factorization is very simple. Applying the formula a square minus b square. Now let's move to example 3. Now one of the term is in the form of fraction, so we don't have to worry about it. Now we have to care is 121 is the square of which number, and 49 is the square of which number, and 1 is the square of which number. Now you can see on the right of your screen that 1 is the square of 1 square, 121 is a square of 11 square, 49 is the square of 7 square. 49 is a 7 square gives the 49 is 49 is the square of 7, and 121 is the square of 11, and 1 is the square of 1. So solution 121y square. Now we have to change this as a difference of the square. You can see 121 is the square of 11, and 49 is the square of 7. So instead of 121y square, we can write 11y whole square, and 1 is the square of 1 itself. So 49 is z is the square of 7z. So which is in the difference of the square, which is in the form of difference of the square, which you can write is a square minus b square. Now it's clear right here is a is equal to 11y and b is equal to 1 by 7z. So instead of a we have to write 11y, instead of b we have to write 1 by 7z. Now we have the formula is there, and it's a confirmation that a is 11y and b is 1 by 7z. Now let's apply it. Let's replace a by 11y. A is replaced by 11y. B is replaced by 7z. You can see a 11y, b is 1 by 7z. A 11y, b 1 by 7z. Now let's answer. Okay. Now 11y square is 121y square, and this is fraction. This is our answer. Just you have to keep the value on a formula, value of a and b on a formula. It is as easy as. Let's see the next example, example 4. we have our example 4. Factorize x plus 3 square minus 289. Now it is already in the form of square. We can change to 89 in the form of a square, like it's 17 square. We can see on the right side solution. It's our quotient. Now we have to, you can see here it's a 17 square is 289, and we have to express this given algebraic expression. It is an algebraic expression as a difference of a square. Now let's change it, let's convert it as a difference of a square. Now it is exactly a difference of a square. Now a minus b, a square minus b square, we can easily distinguish the value of a is x plus 3, it's the value of a, and now here it's the value of b. Now value of b is 7, isn't it? Value of b is 17 and value of a is x plus 3. Now we have to apply the formula. A square minus b square is equal to a plus b, a minus b. Confirmation that a is a plus 3 and b is 17. Now we have to replace a by x plus 3, a by x plus 3 and b by 17. Now see, it's a, x plus 3 is a, x plus 3 is a, and b is 17. A, you can see it's x plus 3 and b is 17. So it's our answer. What we have to do is we have to add 3 and 17. The sum of 3 and 17 is 20. We have to subtract 3 and 17. The difference of 3 and 17 is minus 14. So it's written here. You can use your calculator also. Now this is our answer. Therefore, now here it's 17 square is 289. It is exactly as it is. This is our answer. Example 5. P4, p to the power 4 minus 49. This is an algebraic expression. We have to convert this algebraic expression as a difference of the square. Now first thing is we have to convert the algebraic expression as a difference of the square. That's our first task. Now you can see 49 is the square of 7. So then what is p to the power 4? P to the power 4 is p square dot p square. Now there are two terms which are same. Is it the same term? So we can write p square and outside the bracket 2, which is equivalent to p to the power 4. Okay. Now instead of p4, what we are going to write is p square whole square. And 49, that's the square of 7. Now our algebraic expression is in the form of difference of square. So which is equal to a square minus b square. Now a is p square. Now don't make mistake here. A is not p, it's p square. Now b is, we can easily guess it is b is 7. B is 7. B is 7 and a is p square. We have our formula a square minus b square is equal to a plus b and a minus b. Now here a is equal to p square. It's a confirmation that a is equal to p square, b is equal to 7. Or now we have to replace a by p square, b by 7, a by p square, b by 7, a by p square and b by 7. Now see this minus part. Is it again the square of difference of the square? Is it again difference of the square? This part only. It's not, because 7 7 is not a square of any number, isn't it? It's a prime number, and it is not a square of. It is a square of root 7, but we don't consider it. It is a square of root 7 square, but we don't consider that. We don't go that much deep in this class. So as a number, 7 is not a square of any whole number, isn't it? 7 is not a square of any whole number, so we have to conclude our question right here. P square whole square is P4. It's a question. You can repeat the question right here, and this part is our answer. So we can proceed in this question, but there will be one question where we have to proceed further also. Example 6. P4 Q4. Here we have to proceed further. Now we have to, these terms are as a difference, but not they are different. They are not in a form difference of square. We have to convert these terms into difference of square. Now how can we do is, we can write P4 as P square whole square. We have already discussed, and in similar way Q to the power 4 can be written as Q square whole square, which is equal to A square minus B square. We can clearly see the value of A will be P square and value of B will be Q square. So we have our formula: A square minus B square is equal to A plus B, A minus B, and our value of A will be P square and value of B will be Q square. Now we have to replace A by P square, B by Q square right here. A is P square, B is Q square, A is P square, B is Q square. Now you can see right here with a different color. You can see with a different color, it is again difference of square. Now if we see difference of square, then what we have to do is we have to proceed further. Now it is a difference of P square minus Q square is again a difference of square, isn't it? If we select this part only, P square minus Q square, what we get is, which is equal to A square minus B square, A square minus B square. So our A will be P and B will be Q. Now applying formula, our formula is A plus B and A minus B. So our A must be replaced by P and B must be replaced by Q, and likewise A must be replaced by P and B must be replaced by Q. Now on further factorization, what we are going to get is P plus Q and P minus Q. So we must include this P plus Q, P minus Q on our answer. Now let's proceed. This factor is again, this is a factor of P to the power 4 and Q to the power 4. P square Q square is a factor. P square Q square is again a factor of P to the power 4 minus Q to the power 4. So this factor is again a difference of square. So we have to proceed further. Now we can't stop here. We can conclude our answer solution here. We have to proceed further. Now while we proceed, the answer we get is P square Q square. We can't do anything here, but we have to proceed further. So which is in the form of A square minus B square. This only is a form of A whole square minus B whole square. So P is A and B is Q. Now it will be P plus Q, P minus Q, which we have already done, which we have already seen. Have P plus Q, P minus Q. Now there is confirmation that applying A square minus B square, A plus B, the formula is A plus B, A minus B, which we have already applied right here. A plus B, A minus B, and instead of A, P is used, and instead of B, Q is used. So this is our answer. Therefore P to the power 4 minus Q to the power 4, it will be P square plus Q square. If there is plus, then we have to leave as it is. If there is minus and still the factor is as a difference of square, then we have to proceed further. So you can pause the video, you can note it down. Now there will be exercise for you. Factorize. There are many questions, 20 questions, and you can apply You can study the, you can apply, you can do as the previous examples which you have already done. Okay, let's proceed. Now factorize by applying the same formula, a square minus b square. It's of type 2, section B. Type 1 we have already done. In this section what we are going to do is, in this type we have to apply the concept of type 1, which is taking common. Okay, what we did on type 1 section A is we took common. It was like the first question was like 6x plus 3, isn't it? It was 6x plus 3. We did very first question as 6x plus 3 and we took common. Then we have to do same thing in this also, and then we have to apply the concept of uh, type 2 section A. The first question we did is a square minus 1. You can see in this video this a square minus 1, factorization of a square minus 1, you can see in this video, and the factorization of 6x plus 3 you can see on a part 1 video. So let's start with the help of these examples. Example 1, factorize x cube minus y, x cube y minus x y cube. Now first keep in mind we have to apply the concept of type 1 section A. Solution here. Now see what we did in type 1 section A, we only focused on the first single term. Now factorization of x cube y is x dot x dot x dot y. Now as x has the power 3, we have to repeat x thrice, and as in the second term, in this term y has the power 3, so we have to repeat y thrice. Now you can see exactly see the common part. X, you can see right here it's common, and y also you can see here it's common. Okay, now it is there, it's underlined. We will pick action from this part. Green, you can see it is picked x, and brown color it's y. X, our xy is common, so what we have to do, the common part we have to take it out from the other terms, and the remaining term will be on bracket. So x dot x is remaining, you can see here x dot x is remaining, and y dot y is remaining, you can see y dot y right here. Now xy is equal to x square minus y square. Now this is type 2 section A. It is difference of the square. It is difference of the square, which is equal to, you can write a square whole square minus b square whole square. You can easily say a is equal to x and b is equal to y. Now see, these steps are learned on type 1 factorization. We have already learned this step on type 1 factorization, which is on part 1 video. And if you want quick access to the link to the part 1 video, it will be on description. Now xy, we have to convert this, isn't it? It's, you can say it's xy and curly bracket a square minus b square and curly bracket close. So if we link here, x is a, and if we link here, y is b. Now applying a square minus b square, which is a plus b, a minus b, and what we are going to use is a is equal to x and b is equal to y. Now let's apply it. Xy, now a plus b, a is x, b is y, a is x, b is y. It's our answer. That's it. For example 2, it will be similar to the previous example. Now first, keep in mind we have to apply the concept, apply the idea of type 1 section A. 5.p square.p. Now we just have to focus on only this. The factorization will be 5.p.p and 20, it's 2.2.5.q.q. It is a factorization of this. Now p is taken as common. What we have to do with common is we have to take it out from the rest of the other terms, and the remaining will be on bracket. You can see p.p 2.2.q.q is the remaining after we took a 5 as common. Now on simplification we can see 5p square 4q square. Now this is in the form of type 2 section A. These 3 steps we have already learned on type 1 factorization. Now what is type 1 factorization? If you are confused, then you can go back to that video and you can learn, then you can again revisit this video. Now we can write our next step as p. We have to express this algebraic expression. We have to express this algebraic expression as a difference of the square. Now we can do 4 is the square of 2, isn't it? So instead of 4, it's written 2q whole square. Now we can easily guess a is p and b is 2q. A is p and b is 2q. Now applying a square minus b square, which is equal to a plus b, a minus b, and a is equal to p. You can see a is equal to b is equal to 2q. Now we have to write 5 first, equal to 5 first, then we have to apply the formula a plus b. You can see a is p and b is 2q. A is p and b is 2q. This is our answer. Therefore, first separate the common part, then you can apply the concept which we have just learned in this video. Okay, let's quickly move to another. Now this is very important example. All examples are important. This is also very important. Now the second term is in the form of fraction, so we don't have to worry about it. If we do our basic, then we can easily we can do any equation easily. Now see the 2 on the red color, that's common, so we have to separate the common from the rest of the other. Now remaining is p.p from the first term and 3.3 on numerator, q.q on denominator on second term. Now what we can do is 2p square minus 9 upon q square. These 3 steps we have learned on type 1 factorization. Now let's proceed further. Let's express this algebraic expression in the form difference of the square. Difference of the square. See, p square is written as p whole square and 9 by q square. 9 is a square of 3. 9 is a square of 3 and q square is a square of q. So it is written as a single term. Now what a? You can easily guess our a is p. A is p and b is 3 by q. So if you understand what the value of a and q, if you can find the value of a and q easily, then you can solve the problem easily. Now we have to apply the formula. Applying a square minus b square is equal to, now it's in the form of a square minus b square right here, a square minus b square. So now what's remaining to do is we have to apply the formula a plus b, a minus b. You can see here, which after equal to sign, 2 bracket a is p, so a is p, b is 3 by q, b is 3 by q, a is p and b is 3 by q. That's it. That's our answer. The question looks difficult, but if we stick to our root, our basic, if we go by our base, what we have learned, then we can easily do any questions. Now there will be exercise for you. Factorize. And you can see the question. You have to do all these questions. You have to practice all these questions. They are very useful. Not only on class 8, it will be very useful on class 9, class 10. And if you know algebra properly, then you can learn anything on mathematics. Now factorization by applying the same formula, it is type 2 section C, and here what we are going to do is application of formula. It is used on a practical way. Our formula will be used on practical way. We are going to learn practical use of this formula. In practical, in sense that in engineering or in any construction, in our practical life. Example 1, find the area of shaded region from the given figure alongside. Now this is a figure, and its measurement of side are axiom, so we can easily guess it is a square, and there is another square of 2 cm, and as all sides are equal, we can easily say it is also a square. So we have to find the area of this shaded region. Shaded region means which is in the red color. You can see this, it's in red color. Now we have to find the area of region which is on red color. This is this part. So what we have to do, we have to apply our formula a square minus b square, because as they are in the form of a square, isn't it? The both are square, the bigger square and the smaller square. Let's start our solution for bigger square. Now you may wonder how we knew square. So for the confirmation is there, as all sides are equal, that's how we knew it is a square. Okay, now let's length of the square, of the bigger square. You just focus on the bigger square right now. Its length is axiom, and area, you must know the formula to find the area of a square, that is L square, isn't it? It's written A1 is used for to represent the area of bigger square. Representation is crucial because it won't confuse us. So what is the value of L? L is axiom, so it will be axiom only, x square and cm square. So now it's not a value, it's x, so we just have to leave it here. Now for the smaller square, length is 2 cm, isn't it? Its length is 2 cm. You can easily see in the figure, and its area, it's represented as a square, area of square a2, a1 for bigger square, a2 for smaller square, and the formula is L square. Our value of L is 2 cm. Let's apply it. L is 2 cm. Now it will be 4 cm square. 4 cm square. Now to find the area of shaded region, what we have to do is we have area of a shaded region, which is in red color. A is equal to a1 minus a2. Bigger minus smaller. Always remember, bigger figure minus smaller figure. The area of bigger figure is a1. Area of smaller figure is a2. Now a1 is x square, cm square. We have to replace the value of a1, which is x square, cm square, and we have to replace the value of a2, which is 4 cm square. Now let's convert into difference of the square. Now it is exactly in the difference of the square. It's application of a square minus b square. So we have to convert it into a square minus b square. We have to convert it, or we have to change in the shape, in the form of difference of the square. Now applying a square minus b square, which is a square minus b square is a plus b, and our a is x and our b is 2. You can see a is x and b is 2. How? I don't think you are confused about it. Now a, which is equal to a, difference of the square means a square minus b square. The standard form of difference of the square is a square minus b square. So our a will be x, our a will be x, and our b will be 2. Isn't it? A will be x and b will be 2. Now let's replace it, which is equal to, now see here, A is x, B is 2, A is x, and B is 2. And then it's our answer. Now area of saddle region is x plus 2 times x minus 2. Okay. Next, one more example video. Example 2. Area of saddle portion from the adjoining, and also I have to calculate the actual area where the r will be radius, its radius 14 cm and small r will be 7 cm. Now hint is given as the area of square is pi r square. Hint may not be given on examination. You have to remember yourself. Now this is the bigger circle, and its area, its radius is rcm, and you can see the smaller circle in white color. Its radius is small rcm, and their actual value is also given, but we have to apply that actual value at last. Now first we have to calculate the area for bigger circle. Now radius r is capital rcm, and its area will be, we know the area, formula of area is given as a hint, pi r square. Now we have to replace small r by capital R. Like in previous question, this area for the bigger figure is represented as a1, and if while after replacing it will be pi r square. As it's not a value, so we have to leave this and we have to move to for a smaller circle, and for a smaller circle the radius r is r, it's r, so area of circle A2, as a small circle is represented as A2, will be pi r square. Nothing will be replaced, as r is equal to r. So we can find the area of saddle region as in previous question, which is in the, this is the area a saddle region, this part is the saddle region, and if we subtract the bigger circle with the smaller circle, then we can get this part. Okay, now a1 minus a2, we have to replace the value of a1, that is pi r square cm square minus pi r square cm square. Now if we take pi common, we can take pi common easily, as we have already learned factorization. This pi is common, so what we have to do is we have to take the common part out, isn't it? The remaining part, remaining values, remaining terms are inside the bracket. You can see capital R and small r square. Now we have to apply, which is in the form of square of difference of the square, which is in the form of difference of the square. This algebraic expression is in the form of difference of the square. So our a is capital R and our b is small r. B is small r. So our formula, you can see what we did, applying a square minus b square, which is equal to a plus b and a minus b, and our a is capital R and b is small r. So our formula is a plus b, a minus b. You can see right here, a plus b and a minus b. Capital R is a, small r is b. Capital R is a, small r is b. Again, when if we replace with the actual value, capital R with the 14 cm and small r with the 7 cm, then area of saddle region will be actual area. Now that will be pi r square minus r square. From here we can proceed from here also. We can do from here also. You can do from here also. Okay, we will do from this one. Now we will replace the value of capital R. Replace the value of pi as 22 by 7. I think you know it. R as 14 square and small r as 7 square. You can use your calculator. The 14 square will be 22 by 7, and 14 square is 196. 196 minus the 7 square is 49. Now after subtraction and on multiplication, we will get 462 cm square. You can use your calculator and write it. So you will get the exercise. Try this. Now there is a figure. You can use example concept of example 1 in this figure, and example 2 also. Example 1 and 2. Okay, you can, if you have understood example 1 and 2, you can easily do these two questions. And I think this concludes our part 2. Thank you for being with me, and we will meet again on part 3. So do the exercise, give an exercise, and make a proper note, and it will be very helpful for you, um, not only on class 8. If you understood properly, it will be very helpful on class 9, 10, and on further study also. And algebra is a base, algebra is a core of mathematics. To learn mathematics properly, you have to learn algebra properly. Okay, thank you very much.